You are looking at the oldest light ever seen by humans. This is not a reconstruction, not an artistic visualization. This is a real image obtained by the most powerful space telescopes. The light in this photograph began its journey back when neither the Earth nor the Sun existed. In fact, you are now looking billions of years into the past, but what exactly is hidden in these tiny points of light?
What do we know about stars? These objects are visible every night. You just have to look up at the sky. The daytime horizon of the Earth is not empty either. It is adorned by a yellow shining sphere whose name is the Sun. Modern humanity has become so accustomed to the sparkling dots in the sky that it perceives them as something ordinary and not worth paying attention to. Meanwhile, stars are not fully studied and in many ways, unique cosmic furnaces of terrifying size, powered by nuclear fusion. There are billions of them, and each one is remarkable in its own way. For centuries, stories, songs, and legends have been composed about the stars. Sailors and travelers navigated by the myriad constellations. Since ancient times, people have realized that life without them is impossible. Have you ever heard of the oxymoron hot ice or sweet poison? You can safely add another concept to this list: a cold star. Hubble. There are many stars in the universe, but not all of them. For example, celestial bodies have been found that stand apart and until recently were considered only hypothetically possible. Now, their existence has been proven, so it's worth discussing this type in more detail. We're going to talk about brown dwarfs. These are a kind of failed stars weighing up to 7 solar masses, or up to 80 Jupiter masses. Essentially, their entire life cycle is a gradual and inevitable cooling with a slow loss of their star-like properties. The existence of brown dwarfs, like main sequence stars, is sustained by internal thermonuclear reactions, which involve the continuous burning of hydrogen and later helium. But the heat emission of these unusual objects is minimal. It is among them that scientists find celestial bodies that fall under the seemingly contradictory concept mentioned at the beginning of the video. Cold stars are not just a figurative expression. Such objects really exist. But how cold can stars actually get? After all, first and foremost, these are still stars. The standard temperature range of red dwarfs varies from 300 to 3000 Kelvin, or from 27 to 2700 degrees Celsius. Yes, you heard that right. The lower temperature limit is at plus 30 degrees. And that's colder than your freshly brewed tea. But later it turned out that the information provided required significant clarification and adjustment. As soon as such objects began to be discovered en masse, astronomers immediately started classifying them by size, weight, luminosity, and other characteristics. But in this discussion, we are interested exclusively in the T and Y spectral classes of ultra-cool brown dwarfs. The latter was only recently modeled and for a long time was considered purely theoretical. Today we have 3 medalists. Brown dwarfs, which at different times have claimed the title of the coldest star in the universe. Let's start with the bronze medalist. CFB-DSIR 1458 plus 10 Phi. That's the designation in the astronomical catalog for a brown dwarf about 6.15 times the size of Jupiter, discovered in 2010. A telescope installed on the Hawaiian volcano Mauna Kea spotted the faint star. The object of the binary star system is located in the constellation Vulpecula, 104 light-years away from us. Its discovery caused a storm of confusion and excitement in the scientific world, because the temperature of the star was recorded at only 100 degrees. That's the temperature of boiling water. For almost a year, this brown dwarf held the title of the dimmest and coldest star in the observable universe. But in 2011, it lost this honorable status. WISE 1828 plus 2650. Second place in our improvised ranking goes to the brown dwarf from the constellation Lyra. The distance to the Sun is about 47 light-years. The powerful WISE telescope helped discover this unique object. The brown dwarf, WISE 1828 plus 2650, is remarkable for its temperature range, with the lower limit dropping below zero from minus 23 degrees Celsius to plus 127. Another cooling star shares the well-deserved silver medal with this object. WISE 15, 41 minus 22, 50 located almost 18.6 light-years from Earth. A brown dwarf, about the size of Jupiter, but much more massive than our gas giant, boasts an average surface temperature of around 70 degrees Celsius. WISE 0855-0714. At the moment, the absolute gold medalist is a brown dwarf located 7.3 light-years from the solar system in the constellation Hydra. A star was discovered in 2014, which some scientists consider to be a rogue planet. And so far, no object has been able to challenge the supremacy of WISE 0855-0714. The mass of this celestial body is 10 times that of Jupiter, which also makes it the lightest dwarf in our immediate vicinity. Its age is about 10 billion years, and its effective temperature is minus 30 degrees Celsius. Overall, the range is from minus 13 to minus 43. Scientists continue to study the object, and as a result, they've managed to discover some remarkable details. For example, astronomers from the University of Edinburgh, while studying the atmospheric layers of the failed star, discovered a 100-kilometer layer with a constant temperature ranging from 23 to minus 73 degrees Celsius. According to experts, organic life could very well have originated in this location. If it weren't for observing in the infrared, these cold and very dim objects would never have been seen, even with the most powerful telescopes. Moreover, at first, when scientists discovered the first brown dwarf, they mistook it for a very distant star. Astronomers simply couldn't believe that such a nearby celestial body could be so faint and dim. Despite the weak luminosity of these stars, there is a hypothesis that in the habitable zone of brown dwarfs, it is potentially possible for exoplanets to exist with suitable conditions for the emergence of simple life forms. But it's not that simple. The problem lies in the gradual shrinking of the potentially habitable region as the parent star cools down. Since such planets have to be much closer to their dying star than we are to the Sun, years on them pass in just a few days. Astronomers have also calculated the approximate period during which a distant planet in a brown dwarf system can remain in the habitable zone. It ranges from 4 to 10 billion years. After watching the movie Arrival, I started thinking about time. But not about non-linear time, which we usually experience, but about other concepts of time. So I decided to look into this question and find information about what an expert like Neil deGrasse Tyson thinks about the varieties of time. And I came to the following conclusions. Neil notes, before it became relativistic, our concept of time was something like we all live by the same clock. A second for you is the same as a second for me. This is linear time. Linear means that in length, one interval is exactly the same as another, and one follows after the other. Relativity, on the other hand, showed us that there is no such thing as absolute time. Time is relative. Therefore, it can stretch for me in relation to you. Therefore, time has something like multiple parallel speeds at which it flows, depending on the location of the observer and the location of the one in motion, and what states they are in. And now let's think about dimensions. In our time, we are prisoners of the present, constantly moving from the past to the future, so we don't know how to access other points on our timeline. It is assumed that you can move along your timeline just as freely as when moving left and right, up and down, forward and backward. This refers to the first, second, and third dimensions, and that time is the fourth. In that case, you can return to your own time period. In these states, you haven't died, you're dying all the time. You weren't born, you're constantly being born. It's like you're constantly being given birth to. That's another interesting way to think about time. So, what we don't know is exactly the topics touched upon in the movie Arrival. If you step back into your own life at a different point in time, you'll have to ask yourself if there's any benefit in knowing what will happen in the future. You can come back from the future to the past and maybe bring with you the knowledge of what's to come because you've already experienced it all. But if you return from the present to the future, will you experience everything you would have gone through without the time travel? That's a good question, isn't it? Because if your timeline already exists, you can't change what you're destined to experience. It's already predetermined. But let's say you had the knowledge and the ability to change it. Then you would have to deal with a completely different timeline. And it would become an increasingly complex, almost fractal-like structure. What gets me about Terminator is that he has to kill every woman who could possibly be the mother of the man who starts all the trouble. That was the whole point. I was thinking, why don't they just go a little further back in time? You can go a little further back. You just need to change one small detail, and everything after that would be different. It wouldn't be so bloody, but it also wouldn't be as funny. But this actually brings us to an interesting concept that I've been thinking about a lot lately. For example, with Terminator. It's a loop paradox where their return to the past is the original cause of all the actions. But who has rewatched the movie Somewhere in Time? Yes, many will say that the movie is girly, that's why they skipped it. So it was a romantic love story, and it even has Christopher Reeve in it, actually. Some elderly lady comes up to him, gives him something like a locket, and says something. She says, "Meet me in the past," or something like that, okay? And he's a young guy, and he figures out how to get to the past and meet her. And now they're the same age, and they start a romance, and he gives her that little locket. Okay? Now she has the locket to give it to him in the future. This is what's called Jim's particle in time travel. So this particle was never actually created. It was neither created nor destroyed. It exists only in a time loop. So what is it? Is it considered something that we think should or shouldn't exist in the physical world? Which of course we've gotten used to? Where did it even come from? Did it just exist? That's right, it just existed. It's his attempt to change the state of things and their movement, and that's what makes everything happen. Dwarfs. And it's never going to end. I mean, it's something like the example I gave in like the Terminator. It's a loop that never ends and you'll never get out of it. But in the case of Somewhere in Time, where Jim's particle remains forever in the loop, the characters continue to live. In the Terminator, there were events that affected the whole world. So does a world arise on the other side? I guess not. Because they affected the whole world, because it's stuck in a loop and nothing continues. If it were some old lady who came back to meet someone, then the world would be preserved. But wouldn't we say then This is, of course, a bit speculative, but if I, Christopher Riff, go back into the past, doesn't that mean that everything around me shouldn't be the same as before? Can they be different? Or are they stuck in the same loop as I am? That wasn't the message of the movie, but it should have been. These are questions I want to know the answer to. So, what can be said about the movie The Time Machine? They dealt with an interesting phenomenon. When his beloved dies, she's robbed or something like that, killed in the park. That's why I have a time machine. I can fix it. And now she goes somewhere else, but not to the crime scene, and then she kind of gets hit by a car, and she dies. He repeats it again. She dies every time. He understands that some things are just meant to be. But I thought about it and said why her death was more significant than the robbery itself or anything else. This is a changeable event. Because it changed the timeline for all these people, and probably the robber's life changed as well. The driver is also not the same as before, just to kill his beloved. Yeah, just to kill one person. The time machine is an interesting case. I always thought it was interesting how exactly a time machine works. But when he's inside, he sees everything outside rushing past him. But I always imagined it from the perspective of someone who is just passing by. He just looks at the guy sitting while in the car, like, okay, that's boring. Or it would all happen in an instant. So he's actually moving through time and not things rushing past him? Some moments as he rushes past you would never even see. That is, it would happen so quickly. That's my interpretation. Because I thought it would be a specific place where he would kind of get stuck at that point on Earth so that he wouldn't move. But for us in the time machine, time, since it's relative, feels like it's moving. So they won't see it, right? Well, if the planet moves somewhere completely different, you'll just be in the middle of space. But if it goes back exactly 30 years, then the Earth will return to where it was at that moment, right? So, because he's going back in time less than that interval, he's in the middle of space. And here's an interesting problem. Let's say that tachyon communication exists. That means I can send a message back in time. And you're walking down the hallway and you slip on a banana peel. When I first saw people, well, cartoon characters slipping on a banana peel, I said, first of all, why is that peel just lying there? And second, are they really that slippery? I started throwing banana peels and trying to slip on them. I couldn't do it, and then I realized that you just need to put it down with the inside facing up. But when I turned it over, I said, whoa, it's really slippery. But if you toss a banana peel, it will never land on the ground like an octopus. So you slip, and I say, oh, let me warn him. And I send you a message 10 seconds before the event. You're walking down the hallway when your phone vibrates. You take it out, and it says, beware of the banana peel. But now you're not watching your step, and you slip for another reason, which just happened to become the primary cause. But that's interesting because it's the butterfly effect. Where we change the timeline, for all we know, we might just be a ripple in another universe compared to the one that was. It's like people who say if one thing hadn't happened to George Washington or to Napoleon or Hitler, then the world would be different. And I think, okay, it seems to me you're overestimating that moment, that little incident. They lose sight of the fact that certain forces are at work to guide culture, civilization in a certain direction. They can be unshakable when it comes to certain changes you might make, which you think will lead to a huge difference in outcomes. If we hadn't accidentally discovered penicillin last year, then millions of people would have died by now. You know, Betty Lee would have discovered penicillin a year later, so you're exaggerating this one detail and telling me that civilization would have been different. I'm not buying it. Civilization is much more resilient than that, and if Hitler had been killed as a child, then no, probably not. The Germans were determined to have someone who would take control out of the hysteria. And maybe the consequences made Hitler, not Hitler, who created the circumstances. That's why you're worried that the whole butterfly effect might somehow change the course in that direction, rather than just changing something insignificant, but still within the same overall picture. Because of all these things we've talked about, the butterfly effect seems the most realistic, even though it's not something we can actually calculate, but we can say that anything can happen. Like there are always different changes that happen to people throughout history, or in the present, or in the future. And I'll say it wasn't this butterfly, it was another butterfly. Once there was a headline in the Journal of Irreproducible Results. That's the one where scientists who want to take a break from their regular jobs and come up with some crazy scientific theory, which turns out to be absolutely silly, but is still scientifically approved. And there was a headline that said, "We have photographed the actual butterfly that caused the southern hurricanes." I think in the end, I'll agree with Stephen Hawking that we will discover new laws of physics that will predict time travel to the past. And we don't know what that law is or why it should exist. Everything we can imagine that would allow this to happen completely confuses everything. You see the protesters on the street, you know their slogan. What do we want? A time machine. When do we want it? Well, it doesn't matter. Any time will be fine. So you could argue that if a time machine is ever invented in the future, there's no evidence that it has appeared in our past. But that shouldn't stop us from thinking about it in fun situations and talking about life in this revised life. It's about constantly being born, constantly living, and constantly dying. I would actually get comfortable. And then, the machine shows that your life is predetermined. Even if its essence is to be a hostage of the present, moving from the past to the future, I have the illusion of free will, and I am happy to live in this illusion knowing that it's not true. Reflections on the time machine, when everything comes down to something like predestination, or things that are predetermined on this path that you follow. Time travel kind of makes everything seem predetermined. And there's no way to deviate from the course of this path. Everything you do has already happened. If I get into the time machine, everything actually led up to this moment. Then my past self will go and get into the time machine, and this will happen endlessly. Imagine if NASA announced the discovery of alien life, Martian bacteria, blue whales on Europa, or the ruins of an ancient civilization. Wouldn't that be wonderful? No. Perhaps this news will mean that the end of humanity is practically inevitable and that it might be too close. Why would that be? And why could the most incredible discovery in human history be so terrible? While you're enjoying a cup of coffee and going on YouTube to watch a new educational video on the Hubble channel, it's quite possible that the Great Filter is already somewhere nearby, gazing into the sparkling emptiness of the night horizon and wondering, what? According to the most modest estimates by scientists, for every grain of sand on Earth's beaches, there are 500 billion stars similar to the Sun, and about 100 billion Earth-like planets. Remember that next time you relax on the ocean shore. Even if life developed on just one out of every 100 planets, and on just one of those, life reached an intelligent level, then 10 million billion advanced civilizations should be surrounding us in the universe. It's probably hard for you to even imagine that right now. Am I right? There should be about 100,000 of them in the Milky Way alone, and many of them are billions of years older than us. For people today, such worlds would be just as incomprehensible as 21st century civilization would be to medieval knights. Let's suppose that at least one of these worlds has reached the third level on the Kardashev scale. That means the civilization could very well have launched an expedition with an unmanned self-replicating ship, which, even at a speed far from the speed of light, would have colonized the galaxy in 4 million years. That's just seconds when we're talking about 1 billion years. Realizing this information, it's strange to hear dead silence through radio telescopes. Where is everyone? Are we really alone in this great pageant of life? And what does the great filter have to do with it? Let's take it step by step. Questions. They are precisely what underlie the well-known Fermi paradox. But the way modern scientists discuss this problem is reminiscent of how thinkers in past centuries tried to determine the shape of the Earth, figure out the structure of the solar system, and ponder whether metal attracts lightning. In terms of primitiveness, the level is almost the same. Picture life's development on a planet as a staircase. The first step is the chemical reactions that led to the emergence of living cells. The second step is the development of organisms, whose organization gradually became more complex, and the diversity of species increased. The third step is the appearance of a being with actively developing intelligence, which gradually became the dominant species. A few steps higher, and this being longed to leave the planet that had nurtured it. It is at this stage that we are now. What is the next stage of civilization's development? The answer is logical: colonization of the solar system and moving further. The result of the process is reaching the level of a galactic civilization. It is quite possible that the mentioned algorithm is universal. But then why do we not see or hear anyone? Most likely, there is a serious obstacle that makes becoming this kind of civilization extremely problematic. The great filter is what, according to Robert Hansen, destroys any form of life that encounters it. In our case, there are two options. Either we have already been filtered, meaning we've passed an almost impossible obstacle, or the great filter is still ahead of us. In the first case, we are an incredibly lucky civilization, an exception to the universal rule. In the second, we are doomed to inevitable extinction. The probability of the latter scenario becomes more likely the more easily evolution unfolded in the past. What could have been the great filter for humanity? Perhaps it's the very fact of the origin of life. Essentially, the emergence of life from non-living matter is an extraordinary phenomenon. The second challenge is cellular life becoming more complex and developing into complex organisms. At this stage, a very unusual event occurred, and as far as we know, it happened only once. A primitive predator cell engulfed another cell, but instead of eating it, it formed an alliance with it. This way, it gained the ability to interact with the external environment. This accidental alliance of cells led to the emergence of majestic lions, birds with bright plumage, and people who passionately read fiction and dream of the vastness of space. Intellect brings both happiness and misfortune. Thanks to it, humanity has traveled a thorny path from digging sticks to computers in just 200,000 years. But the brain is a costly luxury for the body because of its high energy consumption. The fact that evolution made a breakthrough only once, allowing humans to significantly surpass other species, may also be that very decisive test. Just think about it. Every animal on the planet is made up of such cells. There may be billions of planets in the Milky Way covered with bacteria, but on none of these planets, except ours, has our level of intelligence been reached. But what if the great filter lies ahead of us? Then it means that the obstacle will be incomparable to those we faced before, and judging by the dead silence of the radio telescopes, no one has survived the test. It's not a major cataclysm because after that recovery is possible, even if humanity is thrown back many centuries. It's something an order of magnitude more dangerous and fatal. What is most discouraging is the hypothesis that as soon as a species embarks on the path of developing an intergalactic civilization, it is doomed. Scientists often consider self-destruction likely. An advanced civilization can do this in many ways. Global nuclear war, technologies that have gotten out of control, nanosphere, genetic engineering, medicine, creation of an indestructible supermicrobe, cybernetics, artificial intelligence that kills its creators, a failed scientific experiment that could destroy the atmospheric layer. Any species that reaches a high level will most likely, unintentionally, make the planet uninhabitable 100 times out of 100. Let's hope that such adventures aren't our fate. And yet, if the filter is ahead of us, our chances are very bad. That's why discovering life beyond Earth could be a terrible event. The more widespread life is in the universe and the more developed and complex it is, the more likely it is that the great filter is ahead of us. Bacteria are bad news. Small animals are even worse. Intelligent life is a reason to panic. The ruins of ancient alien civilizations are terrifying. The best option for us right now is that Mars is sterile. The oceans of Europa are lifeless, and the vast arms of the Milky Way hide only empty oceans, washing over dead continents. How likely is it that we will discover life beyond Earth that is similar to us? But that depends on how many planets orbit in the habitable zone around their stars, where water can exist in liquid form. Since stars can have different sizes and compositions, the habitable zone in each star system is unique, so precise calculations are needed to determine where it is. So at this stage, truly, no news is the best news for Earthlings. Well, that's a brief summary about it. We're very glad that you find joy, love, and learn new things. The Hubble channel will be happy to help you with that. All you need to do is give this video a big like, hit the subscribe button, and wait for the next episode. And it's coming very soon. Really very soon. On the distant outskirts of the solar system, an object named after the Greek goddess of discord is orbiting. The name seemed prophetic, since debates about this celestial body have not subsided for many years, or is considered the object that caused the hasty expulsion of Pluto from the ranks of planets. How did the intrigue of cosmic proportions unfold? Hubble. 136,199 Eris was discovered on the evening of January 5, 2005. The names of the astronomers who first saw its reddish glow: David Rabinowitz, Michael Brown, and Chadwick Trujillo. You might ask, what's so remarkable about this? A lot of new objects are discovered every day, and you would be wrong. This is a special case. First of all, a celestial body of this size has been discovered in the solar system for the first time since Pluto. Secondly, at the moment, this is the most massive and the most distant dwarf planet discovered in relative proximity to our star. Immediately after its discovery, astronomers unwittingly became involved in a debate about whether Eris could be granted planetary status and made the 10th in the list. The issue was unexpectedly resolved at a meeting of the International Astronomical Union Assembly, held in Prague in 2006. It was there, on August 24, that a clarified definition was approved, allowing an object to be identified as a planet or removed from the list altogether. After the historic assembly, this is exactly what happened to Pluto, and Eris inadvertently contributed to the implementation of a long-discussed decision. Now both bodies are classified as dwarf planets. After that, the debates around the flamboyant goddess did not subside, but even intensified. Since scientists could not come to a consensus, what should the newly discovered object be called? In addition to Xena, her original name, the following options were proposed: Persephone, Proserpina, Lila, and even Ymir, which was the name of a mythical Scandinavian giant. The first two names were immediately rejected because they already belonged to asteroids. The name Eris was finally approved, although by tradition, names from Greek mythology are used for the traditional planets of the solar system. But in this case, scientists decided to deviate from the accepted algorithm. Let's take a break from scientific debates and take a closer look at this distant world. The dwarf planet is on average 68 astronomical units away from the Sun. That's about 10 billion kilometers. But considering its highly elongated orbit, we can observe an unusual picture. At aphelion, Eris moves away from its parent star by almost 97.6 astronomical units, which is about 14.6 billion kilometers, and at perihelion, it comes as close as 38.5 astronomical units, or about 5.7 billion kilometers. The last time Eris was close to us was in 1977. In 2012, the planet was 96 billion kilometers from the Sun and is currently continuing to approach our star. Now, sunlight has to travel for 12 hours to barely warm the surface of the divine celestial body. Eris will reach the closest point to the Sun in its orbit in the year 2258. Overall, its journey around our star takes a long 5 centuries, plus an extra half a century. What is this object itself? The first problem that awaited astronomers was the unsuccessful attempts to weigh and measure the size of the capricious planet. Eris is very far away, and data on the diameter of the dwarf planet from different sources varied, from 2,400 to 2,600 kilometers. As a result, on November 6, 2010, the most accurate indirect measurements were made, which amounted to 2,326 kilometers. It turns out that Eris is slightly smaller than Pluto. Its diameter traditionally ranges from 2,370 to 2,390 kilometers. But most likely the data will be repeatedly revised, and time itself will determine which one is the size champion. As for Eris's weight, it has been determined relatively accurately. The mass of the planet is slightly greater than that of its distant neighbor Pluto, 1.67 times 10 to the 22nd kilograms. The next debate that arose around the restless planet was about the length of its day. While scientists agreed that its orbit around the Sun takes 561 years, they couldn't reach a consensus for a long time about the length of a day on Eris. Initially, it was believed that its day lasted 8 hours. A year later, astronomers changed their opinion and increased its duration to 5 Earth days. The latest data recorded this figure at 26 hours. That means day and night on Eris are only 26 hours, 2 hours longer than on Earth. How's the weather on that distant planet? As expected, it's hellishly cold there. On Ophelia, the temperature reaches minus 254 degrees Celsius, which is close to absolute zero. But the closer Eris moves toward the Sun, the more comfortable the conditions become. However, you could call them acceptable only for extremophiles, and even then, that's a stretch. But still, at its closest point to our star, the planet will warm up to minus 230 degrees Celsius. Or is an icy body covered with rocks, methane snow, and ethylene ice. At perihelion, the dwarf planet forms a temporary atmospheric layer, brought to life by the liquefaction of frozen gases. This suggests that, with a certain degree of caution, we can assume the presence of weather changes there. It has been calculated that a hazy methane atmosphere will envelop Eris in 2.5 centuries. There is another piece of news about the mysterious celestial body. It is possible that there is a vast internal ocean beneath its surface. Some astronomers draw this conclusion based on the process of radioactive decay. The planet does not orbit alone. It has a satellite located at a distance of 37,000 kilometers, named after the daughter of the Greek goddess of discord, Dysnomia. Is Eris alone in its status as a dwarf planet? Oh no. There are many candidates for this status in the solar system today. The International Astronomical Union, in addition to Eris, has recognized Ceres, Pluto, Haumea, and Makemake as such. But it is believed that there are several times more similar objects. It's a pity, but we won't be able to see when Eris comes closest to the Sun. But in 2032, the launch of an automatic probe is planned, a station that will be able to reach the vicinity of the dwarf planet after a quarter of a century, and humanity will look at it through the eyes of the probe. There's not much time left. Let's arm ourselves with patience and wait. Is it possible to imagine infinity? It's natural for someone to vividly imagine things by comparing them to what they've already seen. For example, you can imagine the height of mountains by comparing them to skyscrapers and towers. And the color characteristics of objects described by adjectives like cherry, lilac, or eggplant are automatically associated in our minds with the fruits and vegetables they're named after. In short, the principle is clear. So let's repeat the question. Is it possible to imagine infinity? The answer is trivial. The human mind is not capable of this, at least not fully. One real thing that most clearly illustrates infinity is the universe itself, the place that contains everything that exists. But is it possible that it is actually finite? Let's not rush to answer and start with the basics. The basics, essentially the Earth, the solar system, the Milky Way, millions of other galaxies, and of course you and I all exist at the epicenter of a shock wave nearly 14 billion years long. According to observations of electromagnetic radiation sent by distant and nearby galaxies, astronomers have long been convinced that visible objects are steadily moving away from each other. No matter where an observer is in the universe, the effect is the same. Everywhere, the web of stars will be spreading out from him in different directions, like a crack on a shattered windshield. Is there a limit to the expansion of the incredible bubble called the universe? Maybe. But pay attention to the following point. We see objects thanks to the light they emit. That is, astronomers on Earth can observe only the stars and galaxies whose light has had time to reach us. Now think about this. If the universe were finite and not too large, we would see not only the light directed straight at us, but also the rays that, after circling around the universe, returned back. In other words, we would observe duplicate images of the same objects. By the way, the analogies used to describe the expanding universe are actually the ones that mislead people the most. For example, to make it easier to understand, the macrocosm is often compared to a yeast-risen cake, where the raisins represent galaxies that move away from each other every moment. Or with ants rapidly running in different directions across the surface of an inflating beach ball. These images lead to subconscious associations that the universe is a huge sphere with no clearly defined edge. But nevertheless, its space has a certain volume and is ultimately finite. The only advantage that such analogies provide is the understanding of a simple truth. The macrocosm is a spatial fabric on which objects lie relatively motionless. Therefore, it's not the galaxies that are moving, but space itself. It is space itself that is continuously expanding. Let's look at the question from another perspective. If we can't imagine something, it doesn't mean it doesn't exist. Nothingness exists. Suppose the universe actually has boundaries. And what is beyond those boundaries? Emptiness? The snow-white haze of the quiet house? The neighboring universe? We'll have to admit that these questions will trouble the minds of great thinkers and ordinary people for a very long time, perhaps forever. By the way, similar thoughts also occurred to the sages of antiquity. For example, Titus Lucretius Carus, in his famous work on the nature of things, spoke unequivocally about the infinity of the universe, considering it an obvious fact that does not require proof. But to hell with philosophy. What does astronomy say about this issue? From the point of view of modern science, the finiteness of the universe depends on the value of the critical density of matter distribution. This parameter is about 1/10,000th of a proton's mass per cubic centimeter of matter. If the density exceeds the critical threshold, then, based on the postulates of the theory of relativity, it can be concluded that the universe is finite. This indicator demonstrates the closed nature of space in itself. Otherwise, when the average density of matter is less than the critical value, the macrocosm is said to be infinite. This theory is beautiful, But what are the actual observations of astronomers? You might laugh, but the density of matter in the universe at the moment is almost equal to the critical value. So the question of whether the space of our common home is limited still remains open. And here, there are two options. Either the calculations are fundamentally wrong due to a lack of information, or existence is openly mocking us. The farther we look into the depths of space, the older layers of the universe we observe. The Hubble telescope has captured the most distant corner of the universe. After analyzing the image, scientists found that the galaxies in this ancient region are very young. Logically, if we look even further, we can see the first stars and clouds of gas. And what happens next? Neutral atoms, ionized plasma, free protons, and the sky, neutrons. If he were curious about what came even earlier, the observer would see spontaneous patches of antimatter and matter, scattered gluons and quarks. That's it, there's no way forward. In front of us is a cosmic roadblock in the form of an infinitely burning singularity. But still, if the archaeologists of space with incredible effort managed to lift the veil of time, then milliseconds before the Big Bang, they would see space writhing in convulsions, rapidly expanding. Where did the extraterrestrial civilizations go? Why is space silent? Where is everyone? That's exactly the kind of hysterical cry scientists all over the world let out, while ufologists just chuckle to themselves. They communicate with humanoids on a daily basis. Seriously though, our planet is truly surrounded by a strange silence. No one has ever tried to contact us or even hint at their existence. Are we really that uninteresting to extraterrestrial civilizations? Let's set aside our insecurities and turn to the terminology. What is an extraterrestrial civilization? These are intelligent societies that developed beyond Earth. Their existence hasn't been proven, but it's statistically likely. With the help of Kepler's all-seeing eye, it has been established that more than 500,000 planets within the boundaries of the Milky Way alone could be habitable. A question in the spirit of Enrico Fermi naturally arises. But where are they all? Are we really that unique? The Fermi paradox has various interpretations. Here are 8 key reasons that could explain this strange silence troubling humanity, the bare minimum. Let's start with the simplest one. Extraterrestrial civilizations exist, but there are far fewer of them than we think. Because of the colossal cosmic distances, we simply can't call or meet each other. Suppose there are only hundreds, not millions. The active search period should be limited to, let's say, 1,000 years. We've been signaling our existence for only a century. We should also consider the automatic weakening of radio signals. It becomes clear that in the vast expanses of the universe, kindred spirits are not destined to meet, at least not in this lifetime. It has been estimated that in the vastness of the Milky Way alone, there may be about 200 civilizations existing unnoticed by each other. Strict filtering. The theory of the Great Filter was proposed in 1996. Its author, Robin Hanson, created this hypothesis specifically to explain the Fermi paradox. Those who prefer a cozy planet to the vastness of the universe are the absolute majority. By the way, let's also include in this category primitive life forms that are basically incapable of making contact. Advanced hackers versus newbies. This option is the opposite of the previous ones. We are so far behind in development that alien races simply aren't interested in making contact with us because they won't get anything useful for themselves from communicating with us. Our communication methods are ancient, our morals outdated, and our technology prehistoric. Never talk to the characters. If we assume that some highly advanced civilization has created a simulated universe for entertainment or other purposes, then we can safely say, reality is nothing more than an illusion. Don't rush to stop watching. Such an explanation of the Fermi paradox makes some sense. It seems that these ideas were expressed by Plato and Aristotle, not the dumbest guys, if you know what I mean. According to modern scientists, there can be many simulation scenarios, but the main principle of any computer game is accumulating wealth and achieving the highest level of comfort. In other words, the point is selfishness, not compassion. Robin Hansen's recommendations are for those convinced they're living in a simulation. Ask the Illuminati. This explanation will appeal to conspiracy theory enthusiasts who are convinced that we are ruled by the Freemasons or the Illuminati. Then aim higher. They are not alone, but regularly communicate with advanced civilizations to receive instructions from the rulers of the Intergalactic Confederation. But the fact of this contact is carefully hidden from ordinary mortals. Independent observers. Perhaps other civilizations see us, but they are in no hurry to make contact. Why? Because they're worried about sharing already scarce resources in the universe. Moreover, they might even disguise themselves in every possible way to avoid attracting unwanted attention. That's why humanity's obsessive self-promotion in space is risky, just as Stephen Hawking warned. Where did the rabbit go? It's a pity that humanity is not able, like Alice from Carol's fairy tale, to peer down into the very depths of the abyss, into the heart of a black hole. Perhaps that's where we'll find the answer to our question, where is everybody? Scientists have proven that inside especially large black holes, there may be a place where space is indistinguishable from ours, which means that planets could exist there, orbiting the center of the singularity in complex closed orbits, just like they orbit the sun. And finally, continuing the topic of singularity, we can assume that alien intelligence may have long ago reached such a high level of technological progress that it became so absorbed in endless development and lost interest in what was happening around it. Simply put, it isolated itself. This can happen after the emergence of super powerful artificial intelligence or a sudden leap in the capabilities of the human brain through biotechnology. Are there boundaries that we will never be able to overcome? Are there places that we will never be able to visit no matter how hard we try? As it turns out, they do exist. Even if we are able to travel in spaceships, we will still remain on our little island in the universe. How is that possible? And how far can we travel? We live in a pretty quiet part of the Milky Way, in a galaxy that's 100,000 light years across. It consists of billions of stars, clouds of stardust, dark matter, black holes, and planets. At the center of this galaxy, there is a supermassive black hole. With the current state of science, a flight to the nearest stars would take millennia, so our galaxy is truly immense. But the Milky Way is not alone. Together with the Andromeda Galaxy and Dwarf galaxies, we are part of the local group. This region of the universe is 10 million light years across, and it's just one of hundreds of galaxy groups in the Laniakea supercluster, which in turn is one of millions of superclusters in the universe. So let's assume that in the future, humanity won't destroy itself or be wiped out by aliens, and we'll be able to develop intergalactic transport according to current understanding of physics. How far would humans be able to go in that case? Theoretically, we would be able to reach the limits of the local group. But this group makes up only 1/1000% of the universe we can observe. Just think about that number. We are limited to an area that's 1/100000%. The very idea that there is a limit for us and that there is such a vast space around us that we will never get to visit is a little frightening. So why can't we cross those boundaries? It's due to the properties of empty space. The empty space of the universe is not actually empty, but has its own inherent energy. On a small scale, there are constant interactions between particles and antiparticles, which are continuously created and annihilate each other. Now let's rewind time to 13.8 billion years ago, when the matter of the cosmos was complete emptiness, right after the Big Bang. The observable universe expanded from the size of a pea to trillions of kilometers in a fraction of a second. This sudden expansion of the universe was so rapid that all quantum fluctuations also expanded, and all subatomic distances turned into galactic ones. After the expansion, gravity began to pull regions toward each other. Over time, the denser regions in the universe grouped together into groups of galaxies, like ours. And only the objects of the local group are bound by this gravity. But why can't we just fly to the neighboring galactic island? All the difficulties are hidden by dark matter. About 6 billion years ago, dark energy took over everything. It is the invisible cause and accelerator of the expansion of the universe. And science still doesn't know what causes dark energy to exist, but we can definitely observe its effects. There are many different objects around our galaxy, but none of these objects are bound to our local group. That's why the more the universe expands, the farther away other islands move from us. Dark energy is pulling the entire universe away from us. And soon, other groups will become inaccessible to us. Even today, the nearest group of galaxies is millions of light years away from us, and all of them are receding at such a speed that we will never be able to catch up with them. While we are moving away, the local group will shrink its boundaries and eventually turn into a giant elliptical galaxy called Milkomeda, and this will happen in just a few million years. At some point, the galaxies outside the local group will move so far away from us that we simply won't be able to see them. And some photons that still manage to reach us will be so distorted that it will be impossible to recognize them. The universe will disappear from our view, and in all directions we can see only endless darkness. People from the distant future will think that nothing exists except for themselves and their galaxy. They will see only endless emptiness and darkness. These people will think that the universe is static and that nothing is happening in it. They won't see cosmic radiation and won't learn about the Big Bang. They simply won't have the opportunities that we have now. Milkomeda will be an island in the darkness, slowly being swallowed by the dark. And yet, the local group contains trillions of stars. It may take several more billion years to study our galaxy, and that's enough for our civilization. Information about a mysterious planet X is appearing more and more often on the internet. That's what they call the planet Nibiru, which according to predictions is supposed to crash into Earth, resulting in the end of the world. As we know, this scenario isn't new. A catastrophe has already been predicted several times. The last time such a prediction was made was in August 2018. But, as you can see, fortunately that didn't happen. Currently, no planetary collisions are being observed, although scientists believe that several million years ago, this phenomenon was widespread. Planetary collisions influence the entire solar system and planets beyond it for a long period of time. It is believed that Uranus was the victim of a major collision. Millions of years ago, an object at least twice the mass of Earth collided violently with the young Uranus. According to researchers, the catastrophic collision was so powerful that it caused a significant tilt in Uranus's axis. This theory explains why the planet has an axial tilt of almost 98 degrees, which is quite dramatic compared to other planets in the solar system. Fortunately, Uranus managed to retain most of its atmosphere, which scientists are still studying today. But not all planetary bodies survive such massive collisions. It is assumed that Earth is at the center of a catastrophic collision that will destroy the planet. The giant impact hypothesis suggests that an object the size of Mars started moving toward Earth more than 4 billion years ago. Fortunately, it collided with our protoplanet and broke into small fragments. According to the theory, all the fragments and other debris left after this collision were sent into Earth's orbit, and over millions of years, they formed the Moon. According to preliminary expert estimates, this process happened a very long time ago. There are examples of planetary collisions that happened much earlier. According to scientists, in the last few thousand years, 2 planets that orbited a young star were involved in a catastrophic collision. As a result of the collision, the smaller planet broke apart into fragments of vaporized rock and metals, which scattered into space. This collision happened relatively recently by cosmic standards. Some remnants are still present in space, as evidenced by data recorded in 2009 by NASA's Spitzer Space Telescope. With the help of the telescope, traces of silicon monoxide gas were detected, a product of the evaporation of a planetary crust. According to scientists, this discovery supports the giant impact hypothesis. So could history repeat itself? Could a planet ever collide with Earth? Scientists say that it's unlikely. Since this didn't happen during the period of frequent planetary collisions, it shouldn't happen now either, when the solar system is stable. Astronomers also assure that thanks to modern technology and powerful equipment, they can predict possible collisions decades before the expected impact. Therefore, the cataclysm can be avoided. So it can be said with confidence that humanity does not need to worry about Planet X wiping us out. But at least not in the coming decades. What if the government covers your living expenses? Would you keep working? Or would you go back to studying? Or would you quit working entirely? So what will you do then? This principle is called Universal Basic Income, or UBI. And this is nothing less than the most ambitious social strategy of our time. In 2017, the idea of basic income is gaining momentum all over the world. The first pilot programs have already been launched, and a growing number of countries are considering the UBI strategy as an alternative to social benefits. How will this work? And what are the key arguments for and against it? Right now, people can't agree on what basic income is or what it should become. Some want to use it to eliminate social benefits and reduce bureaucracy. Others want it in addition to the existing range of social programs, or even for it to be so high that working would not be necessary at all. What level of income would be enough to stay above the poverty line? For Russia, that's about 20,000 rubles per month, or 240,000 rubles per year. This money will not be taxed, and you can do whatever you want with it. In this scenario, UBI is a way to redistribute wealth in society while maintaining a free market. But what if we just give people the money and they spend it on alcohol and stop working? In 2013, the World Bank conducted a study specifically examining this issue. Will poor people spend the money they receive on alcohol or tobacco products? The answer is simple. No, quite the opposite. Other studies have shown that the richer a person becomes, the more alcohol and drugs they consume. A lazy and drunk poor person is more of a stereotype than a reality. What about laziness? If laziness and addiction aren't such a big problem, then why don't current social benefits solve the problem of poverty? Support programs for the poor and unemployed usually have many conditions, such as taking courses, submitting a certain number of job applications, or accepting any job offer. It doesn't matter if the job is suitable or pays well. How economically realistic is this model? What about inflation? Higher prices might just return things to how they were before. Since money isn't created by magic or printers, it has to come from somewhere. It's more of a redistribution of funds than the creation of new ones. Therefore, there is no inflation. Okay, but how will we pay for all this? There is no right answer here since the world is too diverse. How well is that side provided for? What is valued more there? Is it politically acceptable to raise taxes or reduce defense spending? How many social programs are already in place and how effective are they? Every country has its own path to UBI. The simplest way to pay for UBI is to get rid of all other benefits and use the freed up funds to pay for it. This will not only get rid of many government agencies, which in itself saves money. On the other hand, their cancellation could leave many people worse off. If the goal is support for everyone, then some programs will still be needed because, like countries, people are not the same. The second way is higher taxes, especially for the very rich. For example, in Russia, there was significant economic growth, but most of the benefits went to just a few percent of the population. The wealth gap is widening rapidly, and many believe that it's time to distribute the benefits more evenly in order to maintain peace in society. These could be taxes on financial transactions, capital, land, carbon emissions, or even robots. But it's not certain that UBI will be costly. According to a recent study, a UBI of 20,000 rubles in Russia could actually significantly increase the annual GDP, since it would allow the poor to spend more and boost overall demand. What about people doing dirty work? Who will work in the fields, crawl through the sewers, and carry furniture? If it's not necessary for survival, will people continue to do hard, boring, and unsatisfying work? UBI can give them enough resources to demand better pay and working conditions. The rich get richer while the poor stay the same. But we can free a significant part of the population from fear, suffering, and existential panic. Improving the lives of the poor might turn out to be a wise economic tactic. For some, that's not enough. They want UBI to be enough to provide a middle-class standard of living. In 2016, only 33% of working Russians were interested in and satisfied with their jobs and earnings. 16% were clearly unhappy, and the remaining 51% were simply present at their workplace. 67% of people would stop working if they could. It would be unfair to portray work as just a routine. Work gives us something to do, a challenge. It motivates us to grow, it engages us. Many people find friends or partners at work. We work for social status, prosperity, and our place in the world. We search for what to do with our lives, and for many, work gives life meaning. If social programs are replaced with a single payment, it will give the government more influence. Although 20,000 rubles is not bad for the provinces, for expensive metropolitan areas it's not much, which could lead to an outflow of poor residents and a widening gap between the rich and the poor. So can we call universal basic income a good idea? The honest answer is we don't know yet. Much more research, structuring, and pilot programs are needed. We need to think about what type of UBI we want and what we're willing to sacrifice for it. The potential is enormous. This is possibly the most promising model for sustainable poverty eradication. It can seriously reduce the amount of despair in the world and make all of us less irritable.